So again, just for video purposes, to start with, we're going to convert vertex form to standard form. We like vertex form, easy to read the vertex. We don't really like standard form, but it's a good algebra thing to go from one to the other. Minus 2x plus 1 plus 3. 2x squared minus 4x plus 2 plus 3. 2x squared minus 4x plus 5. Okay. Not really a big deal. Not very challenging. What we're going to do today is, like that's not really even helpful though. Like, why would we want it in standard form if we had it in vertex form? So what we're going to do today is the opposite of this. We're going to start in standard form and we're going to convert the other way from standard form to vertex form. We're going to go from standard to vertex. So that's a little bit harder to get from ax squared plus bx plus c, that's standard form, into x minus h squared plus k. But it makes more sense we'd want to go that way because we like vertex form. It's easy to read off the vertex. How do you find the vertex in standard form? Just a reminder. So if you're stuck with this, negative b over 2a, and then you got to plug it back in. So that's kind of annoying, as opposed to, well, the vertex here is h and k. So we're going to take standard form and turn it into vertex form. And kind of the key step here is there's a perfect square in there. And so we need to force there to be a perfect square. So let's do one. We've done this before, we just haven't done it quite like this. So let's convert. Let's start with x squared minus 4x plus 9. And we want to convert that to a vertex form. Again, we want a perfect square in there, so we would like to make that show up, and in order for that to show up, we need to complete the square. So you might have thought we were done with complete the square. We're not. It's a little bit different here, so let's be careful, because usually if we were completing the square, what would we do with that 9? Move it to the other side. Well, I don't really want it on the other side because I still want y equals. So instead of moving it to the other side, this might even look funny what I'm about to do, I'm just going to kind of move it out of the way. Right? So it's still plus 9. It's like, to the back of the line, 9. Get out of my way. I've got work to do. So I'm not moving it over. I'm just moving it out of the way. Now, the steps are the same, like those key steps that we talked about, HSA. What's HSA stand for?
Half it, square it, add it.
Half it, square it, add it. Okay, so half of b is negative 2. Square it, we get 4. So if I put a plus 4 right here, now I've got a perfect square. Now we completed the square. But I can't just go sticking a plus 4 in an equation. That's not legal. What did we usually do when we put plus 4 there? We put it on the other side, which is fine, but I don't really want to mess with the other side because I want y to still be there. So what else could I do to this side of the equation that would keep things balanced? I could minus 4. So plus 4 and minus 4, that doesn't change the equation. So the half it, square it, add it will make this work because now we know how to factor that.
Yeah, but like the number you make. Yeah, how did you have to make it the original number? Because it's 4 and 5. Always has to add something.
Yeah, so like you're like kind of peeking ahead. You're trying to figure out what this is to make 9 work.
Yeah, but always has to like have to.
Correct. And there we go. We're done. I say we're done. What's the vertex of that, just to make sure we remember how to find this? Is that left or right 2?
Right.
And up or down 5? Up. So it's complete the square. I guess it's maybe easier because you don't solve anything. Once you complete the square, you're done, because now you're in vertex form. So, I don't know. If you know complete the square well, it's easier than complete solving by completing the square. But it's still those key steps in there. There is one thing we can do to make it a little bit trickier. So let's make sure we can handle this one. This will be the last example, and then we'll do one or two together off the worksheet. Y equals 2x squared minus 4x minus 3. Okay, what would you like to do first? Okay, yes and no. So Mason's right. Like, we need a equal to 1 because I can't do this with the 2 there. So you're right to call that out. But before I handle that, I still want to move the 3 out of the way. Get out of my way, 3. Got work to do. Let's just put you back here. Now, Mason's right. Can't do this unless a is equal to 1. Previously, we would divide. We'd divide both sides by 2. But I don't want y over 2. I just want y. So what could I do with that 2 instead of dividing by it? That's right. It's like whatever, factor it out. And I don't want to mess with the 3, so I'm still just going to leave the minus 3 out there.
Can you just do the 2x? 2x to get the x out or something?
I'm not sure I understand your question. The 3 is the only thing I want to get out of the way. I'm going to half it square it, add it on the rest, but I can't do that until a equals 1.
Never mind.
Well, first I think it was asking if we could factor out the 2x instead of just 2.
Oh, factor out the 2x? But then it wouldn't look like a quadratic. It wouldn't be an x squared in there. So you're right. Normally, if you're just factoring that, you would take out a 2x. That's right. But my purpose here isn't to factor. My purpose here is to get x squared to have a 1 in front of it, so that we can half it square it add it.
And one more question was, why would we just take off the negative 3 then? Or just do we just put off to the side just, we can just do that?
Yep.
Okay.
Because we haven't done anything to it. We just sort of moved it out of the way.
Okay.
But we didn't take it away. We just,
Right. Okay. So whenever we get to the equation, the last one, we just kind of break it up.
I mean, that plus 9 was still there. It didn't go anywhere. I just moved it out of the way a little bit.
Well, right, but we just didn't include it
In the final answer?
Well, no, I'm just asking, so we just break the whole equation up into 2 pieces?
Kinda.
Okay.
Yeah. Okay, let's half it square it add it. So b over 2 is negative 1. Square that, we get positive 1. So we write plus 1 right there in order to complete the square. But I didn't, when I wrote that, I wrote plus 1, but what did I really add by writing that plus 1? I wrote plus 1, but we really added 2. Why are you saying we added 2?
Because you have a 2.
There's a 2 out front. So I wrote plus 1, but by sticking that plus 1 inside the parentheses, I added 2. Because of that 2. So how do I counter or account for the fact that I just added 2 to this side of the equation? I'll subtract 2. That feels really weird to write plus 1 minus 2. Or it should feel weird. It's like, wait a minute, that's not the same thing. Except it is the same thing because of that 2 out front. So as usual, if our coefficient isn't 1, it complicates things. 2. And then this inside stuff is a perfect square because we completed the square. So x minus 1 squared, and then the stuff at the end is minus 5.
When did you get plus 1?
This plus 1 comes from the half it squared added.
Yes, but that's negative. Oh, but you're putting it into the parentheses.
It's not negative because I squared it. Half it negative 1, square it positive 1, then plus
What
1.
about the negative 2?
So I wrote plus 1, right, to complete the square. That makes that a perfect square.
Okay, what about the 2?
Okay? So I wrote plus 1, but I didn't, that's not really adding 1 to that side. How many did I really add to that side? I wrote plus 1, but I didn't add 1 to that side because there was a 2 out front. So that means I added 2 to that side by writing that plus 1 there.
Added 2? Because of the multiply?
Yeah, because there's a 2 out there. I didn't add 1, I added 2, even though I wrote plus 1. It's weird, but that 2 out there is messing things up.
So you have to multiply it by 2 for the outside?
Correct. Because I can't just go adding 2 to an equation. I could add 2 and subtract 2. Now I haven't changed anything.
It's just really weird without the equal sign separated.
Yes, it's complete the square, but everything's on one side, rather than adding 1 to both sides,
Yeah.
squaring both sides, dividing everything by 2. It's like, no, we got to take care of everything on one side. So you're right, that is a little bit weird. Oh, just as a reminder here, what's the vertex for this guy? 1, negative 5. And that 2 would be the vertical stretch. Okay, well, the assignment is the next worksheet. I guess, good news is we just did number 2, so you can mark that one off. Let's try number 3. That's another one that has a 2 out front. In fact, that's got a negative 2 out front. Let's see, how many steps at once? What am I going to have to factor out to make A equal to 1? Negative 2. And what am I going to do with that negative 118? Yeah, just push it out. Like I don't have to worry about taking 2 out of 118. I'm going to push the 118 out. So x squared plus 16x, and then we'll leave the minus 118 alone. Okay, half it, square it, add it. When I half it, start picking on people here. Layla, when I half it, what do I get? What's that?
Oh, sorry.
8. Oh, you thought that was a 6, I bet.
Yeah.
Yes, half of 16 is 8. All right. Max, I square it. What do I get? 64. Haley's not here. Audrey, what do I do with that 64? No, I mean, I need 64 to be there in order for this to be a perfect square. So I have to write plus 64. I think I know what you're looking at. But I've still got to half it, square it, add it. Now I need to be careful because I need to pause right here because this is not legal what I've just done unless I do something else.
Do you add the 64 to the outside, but you have to multiply it by negative 2?
Right. So I wrote plus 64. You're looking at the right thing. So what did I really just do to this side of the equation? I subtracted 128 because of that negative 2.
120. Oh.
64 times 2? So what do I need to do to keep things in balance here? I need to add 128.
What? No.
Wait, well look, there's a negative 2 out there. So I wrote plus 64, but what that did was subtract 128, and so to counter that, I need to add 128.
This is my least favorite part.
That's easy from here. So x plus 8 squared plus 10. So this page is our homework. Why don't you try number 5, though?
Is that the answer?
So that's the answer, right? This is where it's easier than the other complete the square, because I don't have to square root both sides, plus or minus, simplify. Like, no, I'm just rewriting the equation so that I can tell what the vertex is.
I don't understand
So
why.
the vertex is negative 8, 10.
So it doesn't ask for it, but yes, the vertex is negative 8, 10. And if we wanted to graph it, it'd be flipped and stretched.
Okay.
I don't understand for the negative and plus sign. For like, how did you like? Because it was supposed to be a negative, but you did it for a positive. Why did you do it for a positive?
What was supposed to be negative? This?
128.
Okay. Because even though I wrote plus 64, by putting that right there, I did not add 64 to that equation. I subtracted 128 because of that negative 2.
What?
I wrote plus 64, but I did not add 64 to that equation.
Wait, so just because it's a positive number, 64, you have to keep it positive?
You always half it, square it, add it to make this be a perfect square. That's always plus.
Yeah, always plus.
That's always plus. You still half it, square it, add it.
Yeah, but it's going to be plus anyway. So
That's going to be plus.
yeah.
But because of that negative out front,
Yeah.
I really subtracted 128 when I did that.
It's negative on the outside, but why is it plus on the outside?
Well, I have to make these balance. Right? If x equals 7 and I don't want to change things, I could do plus 5 minus 5. That didn't change anything. That's still going to be 7. That's basically what I'm doing. I'm going minus 128 and plus 128. Try number 5. Try number 5. So factor out the negative 4, move the negative 10 over. So we don't like the negative 4. Maybe I move that 10 out of the way first. Factor out negative 4. That gives me x squared minus 4x. Now I'm ready to half it, square it, add it. So b over 2 is negative 2. Half it. Square it, I get 4. Add it, I get plus 4. So again, you're always still going to half it, square it, add it to figure out what goes in that spot to make that a perfect square. Now I have to account for the fact that I just wrote a plus 4 on the equation. I can't go around just putting plus 4s on things. So I put plus 4, but I really subtracted 16. So how do I balance that out? How do I balance out a minus 16? I need to add 16. So y equals negative 4 out front. Factor the inside, but now the inside factors with that negative 2. Because it always factors with b over 2. And then negative 10 plus 16 is 6. And now we've got it in vertex form.
Are we only doing the odds, or are we doing
We're going to do all of them. There's only 10 of them. There's not a back, so, and we've already done 3 of them, so hey, we're cruising right along. And you got 20 minutes left. You tell me, was there one you want to look at next? Number 8. What do you want to do first on 8? Take out the negative, so that's x squared plus 2x. And then again, we're not worried about the 7, we're just leaving him out to the side. So there's your first step on number 8. So I wrote plus 1, but that's not really a plus 1, right? That's weird. There's a minus sign. So how do I balance out what I wrote out here? Plus 1. And that, I hope that feels weird, because it feels like you just did plus 1, but you didn't really do plus 1, you did minus 1 plus 1. So negative x plus 1 squared plus 8. So you're still doing the half it, square it, add it, but that other term out there is really the tricky one to keep things in balance.
Makes sense.
Ones like number 1 and number 9 are the easier ones because a equals 1. The other ones you've just got to be super careful with. Okay, so we've done 4 of them. I'll stop there. I don't want to steal all your joy from working the problems. I'll let you have some of the fun.
You can take as much as
I don't want to steal your joy. So, I guess maybe to help some of you later, let's go ahead and label this as due on next Wednesday, November 12th. Basically, the rest of the packet's due next Wednesday, November 12th. So you've got 15 minutes left. 6. If you've done one extra, if you can do one in every 3 minutes, you can finish before you leave. Perhaps another no homework night.